Good morning, good evening, good afternoon, everyone. Welcome in Salesforce Apex Hour. My name is Amit Chaudhary, and today we have a very great star, Uncle Bob, and he's going to talk about the clean code. So I will not going to take too much time here. So let me hand over to Uncle Bob.
Hello, everybody. Thanks for attending. This is going to be fun. I'm going to spend a few minutes talking about clean code and what it means to be clean and stuff like that. So let's get moving. This is the book that I wrote some time ago on clean code. Most of the code in this is Java, and so if you're a Java programmer or a .NET programmer, you'll be able to follow along with this code just fine. Why did I write this book? Well, I saw this cartoon long ago in a magazine or an online magazine, and I thought that it was a very good representation of the current state of software development. You know, the only valid measurement of code quality is WTFs per minute, and you can fill in what WTF means. And good code is behind the left door with relatively few WTFs per minute, and bad code is behind the right door with lots and lots of WTFs coming out. And I thought, okay, that's a good way to kick off this idea of clean code. The book is a book that I've wanted to write for a very long time, but I didn't feel like I had the authority to write it. I've been a programmer now. I've been a programmer for well over 50 years. But when I started thinking about this book, I'd only been a programmer for like 35 years. And is that really enough time to have the authority to write a book like this? Do I really know that much about it? But eventually I got to the point where I thought, well, somebody's got to write this doggone book. And so I wrote a book about clean code. You should understand that this is what I think clean code is. You may not. That's completely up to you. These are just my opinions based on many decades of experience. And I believe that experience might be worthwhile. Now, I want to take you through a few interesting discussions. Number one, why does clean code matter? Many of you may have experienced this particular roller coaster ride. You start out on a brand new project, and when the project is brand new, there's no code, how fast can you go? I mean, most people, when there's no code, they can go like lightning, right? You walk up to them and say, hey, can you give me this feature? And they think for a minute, and then they go, yes, and they're typing like mad, and code comes out of every orifice of their body, and then within a week or so, the feature's working. And maybe if you're a manager, you've never seen anything like that before. So you ask timidly again, can you do another feature? Yes, more code. Come back to that team of programmers a year later. Ask them for a feature. Ooh, that's going to be tricky. Probably take us 6 months. Yeah, but you used to get this kind of thing done in a week or two. Yeah, but you don't know how complicated this code has become. Why, if we touch even a line of it, all hell could break loose. Now, I'm playing this up for a good reason, although I imagine there are several of you in the audience who have gone through that precise experience. And now I want you to think about what it does to the productivity of the team. The productivity of the team over time decreases. It decreases asymptotically towards zero. I have worked on teams where no project at all, regardless of how simple, how small, could be estimated at less than 6 weeks. You want to change the name of a menu item? 6 weeks. And why? Why would it take so long? Because no one knew what would happen if even one line of code was changed. and we had a number of very bad experiences with specifically menu name changes, which caused horrible problems downstream. The bottom line here is that as code gets older, it gets worse. And now I want you to ask yourself why. Why does it get worse? Because humans make things better with time. That's what human beings do. Human beings improve things with time. Why does the code get worse with time? Why do the design and the architecture rot with time? It's an interesting question, isn't it? And does it matter? This guy's name is Kent Beck, and he wrote a book a long time ago. The name of the book was Implementation Patterns. Wonderful book, by the way. If you can get it, get it. It's all in Java, and it's all about interesting little things that you can do to make your code look better. And in the preface of this book, he wrote that the book was based on a fragile premise, that good code matters. Now, why did he say that that was a fragile premise? Because I don't think it's a fragile premise at all. I think good code matters. But he said this: it's a fragile premise because clearly there is so much bad code out there that it must not matter. Now, I think it does matter. I think that if you and I and everybody else listening to this focused on the quality of our code, we could dramatically improve this curve. We could keep it from bottoming out. We could continue to go fast if we kept the code clean. Now, most of you probably agree with that. And so then, why don't you keep the code clean? Now, maybe some of you do. Maybe some of you do, but the vast majority of people do not. And why not? Why not? Well, if you ask them, they'll tell you that they don't have time. They don't have time to do the thing that'll make them go fast. They only have the time to do the thing that will make them go slow. I'll leave you to work out the logical inconsistency with that particular attitude. A part of it is the idea that clean code will make you go fast in the long term, but in the short term, to go fast, you have to make a mess. Now, this is dead wrong. and most of you know that it's dead wrong, because most of you have written code in the morning, gone to lunch, come back after lunch, looked at your screen, and wonder what idiot was pounding on the keyboard before lunch, right? Bad code slows you down immediately, not months from now. It slows you down immediately, but it's much worse than that, because bad code doesn't just slow you down, it slows everybody down. Anybody who has to read that code will slow down, and they will slow down every time they have to read that code. So there's this vast multiplication effect. The bad code is an anchor that slows everyone down over and over again. And if that code were clean, nobody would get slowed down. Well, that's the idea behind clean code. Now, there's a whole bunch that we could talk about with regard to clean code. I'm going to focus on a few areas, not too many, because we only have about an hour, and I figure, okay, 45 minutes to an hour is probably all the time I'm going to have to hold your attention. So, first of all, let's talk about what clean code is. So I'm going to bring up this guy. This is Jarno Stroustrup. Some of you know that name. Jarno Stroustrup is the inventor of the language C++. Now, nowadays there's not a lot of stuff being done in C++. It's one of those older languages that we have superseded. Now most people are doing Java or C# or Ruby or Python or Clojure or Elm or Dart or Go. Maybe one day we'll talk about why there are so many languages like that. But I asked Jarno Stroustrup what clean code was. And Jarno said, I like my code to be elegant and efficient. That is the essential Jarno Stroustrup right there, elegance and efficiency. And then he said this: Clean code does one thing well. What's that one thing? Now, this is an old rule, by the way. I mean, software writers have been talking about one thing for decades. And usually they'll say it like this. They'll say a software module should do one thing, do it well, do it only. That's an old rule from, I think it was Tom DeMarco who wrote that 40 years ago. Well, okay, what does that mean? Well, it kind of means that, if you write a function, that function should do one thing. Now, what does that mean? What's one thing? I will tell you that, 40 years ago, I was writing in C, and I wrote a function that was 3,000 lines long. The name of that function was GI, which stood for graphic interpreter, but why spell it out when you can use just 2 letters, right? So GI, graphic interpreter. And if anybody had come to me back then and said, well, Bob, that function of yours does a lot more than one thing, I would have responded and said, no, it interprets graphics. That was one thing to me. You see, the idea of one thing is subjective. You can grow or shrink the concept as much as you like, but I think I know how to make it objective. I think I know a way to define one thing that is indisputable. And I'm going to show you what that is in just a few minutes. I will tell you what one thing really means. but we should move on because we need to talk about this guy. This guy's name is Grady Booch. What a great name, huh? If you had a name like Grady Booch, you could publish a book and no one would forget your name, right? The author of the book, Grady Booch. Now, Grady Booch was the chief scientist at Rational Corporation. Eventually, they got purchased by IBM, and now, well, he used to be a senior fellow at IBM. Now he's retired. He lives on an island in Hawaii. He's a happy guy. Don't worry about Grady. But I asked Grady long ago, Grady, what's clean code? And he said to me, clean code is simple and direct. Clean code reads like well-written prose. Now you think of that last line there, right? When's the last time you read code that read like well-written prose? Most code does not read like well-written prose. And when I first read this from Grady, I kind of scratched my head and thought, well, what the heck is he talking about? But I think I know. I think I know what he was talking about. I think I know how to make code read like well-written prose, and I'm going to show you how to do that in just a few minutes. But there's somebody else I'd like to introduce you to. His name is Michael Feathers. Michael Feathers wrote a wonderful book. It's called Working Effectively with Legacy Code. You should go get this book if you don't have it. You should read the book. It's a wonderful book, very depressing. It will tell you how to deal with legacy code, and it's not easy dealing with legacy code, but he wrote the book on the topic, and it's a great book. And when I asked him what clean code was, he said, and I love this, right? Clean code always looks like it was written by someone who cares. When is the last time you read code and you thought that it was written by someone who cared about you? Maybe they cared about getting it to work. Maybe they cared about checking it in. Maybe they cared about meeting the deadline, but did they care about you? That's the kind of code we want to write. When you read code, and as you're reading it, you think, my goodness, this person cared about me, cared to make this code easy for me to read, to understand, to manipulate, to change. Well, then you must have pretty clean code. One more of these. Ward Cunningham. Now, maybe some of you know who Ward Cunningham is. Maybe some of you don't. Ward Cunningham is It's hard to describe. First of all, he's the inventor of Wiki. So if you've ever used a Wiki, and you've all used Wikis, I'm sure. Well, he's the guy that invented the Wiki. He wrote the very first Wikis in the 1980s on a Macintosh using HyperCard. Later on, he learned some Perl and he put one online. The very first Wiki ever is c2.com. The letter C, the number 2.com. You can go to that and you will see the very first Wiki ever. It's big, dude, a lot of stuff in that Wiki. But I don't want to get too focused on that because Ward is much more than just the inventor of wikis. Ward is the guy who had a conversation with Eric Gamma and told him he ought to write a book called Design Patterns. Ward is the guy who worked with Kent Beck while they invented things like test-driven development and pair programming and most of what we now call Agile. Ward Cunningham is this fatherly-like figure who kind of sits in the background and very few people know who he is, but he pulls on little strings and causes vast waves in our industry. So I wrote to Ward, I said, Ward, what's clean code? And he wrote back to me. And you know how old this guy is by looking at the wording here, right? You know you are working on clean code when each routine you read turns out to be pretty much what you expected. Now, when I first read that, I thought, well, crap, what the heck does he mean by that? But then I thought about it for a while, and I realized, when was the last time I read code and it was just what I expected it to be? When was the last time that I read code and I agreed with it? Think about yourself, right? You're reading code. Is this how you read code? Do you go, yeah, yes, yep, yes, aha, yes. Is that how you read code? Or are there a bunch of WTFs coming from behind the door? Yeah, see, Ward's idea is that the WTFs per minute should be 0. It's pretty much what you expected. Well, enough of that. That's what these folks thought was clean code, and I thought you might enjoy that little foray down that particular lane. But I want to talk about functions. Now, there's a lot of other things we could talk about. We could talk about names. We could talk about comments. Maybe we will get a chance to talk about comments. Depends on how long this takes. But there's a whole bunch of things we could talk about. But I wanted to spend some time on functions. I'm going to show you a function. I'm going to give you 2 minutes. It's 3 pages long. I'm going to kind of cycle through the page, roughly 1 minute per page. The last page is only half a page. So yeah, man, roughly 2.5 minutes. And I want you to look at this code and see if you can work out what it does. And we're going to begin that right now. I'm going to be quiet. You read the code. Here comes the next page. Okay, one last page, only 30 seconds now. Okay, good enough time. Now, what did that code do? Well, I'll tell you what it did. Okay, this is code in a tool called Fitness, F-I-T-N-E-S-S-E. You can learn more about this tool by going to fitness.org. What this function does is it takes one wiki page, which happens to be marked as a test page, and then it finds a setup page that applies to it and a teardown page that applies to it, and it surrounds the test page with the setup and the teardown. Then it converts the entire thing to HTML because it's initially written in wiki markup language. So it converts the whole thing to HTML and then sends it to the testing engine. That's what this does. It surrounds the test page with setups and teardowns. Okay, now let's look at this code. What's the name of this function? Well, the name of the function is testable HTML. That's a stupid name, isn't it? First of all, it's a noun. Functions should never be named with nouns. Functions do things. Functions are verbs. So at very least, this function should be named produce testable HTML, but even that's a terrible name because it doesn't tell you what the heck the function does. We'll look later at what the name of the function really ought to be. But let's look deeper here because there's so much to learn about how to not write code in here. Look here at wiki page. I believe you can see my mouse. So look at where my mouse is. And you see this wiki page equals new page data.get wiki page. Now, if you were a programmer on this project, this would make you feel good because there is no higher level concept in fitness than the wiki page. The wiki page is at the top level of the abstraction hierarchy. So if you're a programmer, you're looking at that going, oh, good, all right. I know where I am. I'm at the wiki page, right? High level abstraction at the top. Now look at the next line.
Sorry, I couldn't hear what you said.
Siri, dumb Siri, don't interrupt me again. Now look at the next line, right? String buffer. String buffer. Now, that's about as low level a concept as you can get. and notice how long it took us to go from the highest possible level in the system to the lowest nitty-gritty detail. It took one line. That's rude. That is rude. If you're a programmer and you're reading that, you feel like the programmer who wrote it is rude. Why? Because you're all ready to accept this high-level concept, and then the author makes you take that high-level concept and push it on your mental stack so that you can deal with this low-level concept. And then once you've dealt with the low-level concept, then you have to pop your high-level stack back. Now, the problem with that is that we do not have a stack in our brains. We're not very good at that kind of thing. And if you want proof of that, just interrupt a programmer when they're deep in thought and see how much they enjoy that, see how much they appreciate you. No, this was rude. This guy, the author of this code, and I don't know who it was, could have been me. It might have not have been me, it might have been someone else. Anyway, the author of this code was rude. Now, I'll tell you why he was rude in a little while. There's a reason. But for now, let's just say he was rude. He goes from the highest level concept to the lowest level concept in one line. Then he climbs right back up into high level concepts, right? Whether the page has an attribute and whether, oh, let's go get the inherited page from the page crawler. And so he's dealing with a wiki page. He's really way back up at the highest level. And all of a sudden there's a null check. A null check. Another one of these low level details. Now, if you think about this, this is an up and down roller coaster ride through the levels of abstraction. And that is always rude. It's always rude to take your reader up and down through the levels of abstraction. Why did the author do this? Well, the author did that because that's the way we write code. When you're writing code, this is how you write it, right? You think, okay, I need a wiki page. All right, wiki page. Okay, all right. Oh, I'm gonna need a string buffer. Okay, string buffer. Yeah, okay. Oh yeah, wait. If it's a test page, I'm gonna have to get the inherited pages. You see, you're thinking up and down the levels. That's how you write it. Everybody writes code that way. The problem here is that the author left it that way. The author got it to work and then committed the ultimate sin. He checked it in. You don't check the code in when it works. You check the code in when it's done. Not when it works, when it's done. And it's not done until it looks like it was written by someone who cares. Now, I'm going to show you how to do that in just a minute. But let's keep looking at this code because there's much to learn here. I want you to look here at this null check, which is followed by a page crawler, which is followed by 3 appends. Now, is that dot important? Notice how, we've gone from the highest level abstraction in the system to a dot. Now we're dealing with a dot. Is that dot important? I mean, that's how rude this code is. Okay, all right, so null check. There's the null check. There's the page crawler. Then the 3 appends. Let's go to the next page. Oh, look, null check. Page crawler. 3 appends. You think there may have been a little copy paste going on here? Yeah, okay, let's keep going. Oh, look, null check. Page crawler. 4 appends. 4 appends. Oh my goodness, that first append, that's an extra line end. Is that extra line end important? Does that extra line end have to be there? Let's go to the next page. Oh goodness, null check. Page crawler, 3 appends. What happened here? Well, the programmer got the first batch to work, and then he realized that the other 3 were just going to be real similar to that. So he used copy paste, and he went paste, 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 and then he fiddled in the other ones, got them to work too. And then when he got everything to work, he checked it in. That was the flaw. He checked it in. He didn't fix it. He didn't make it readable. He didn't make it right. Now, most programmers make that mistake. They think they're done when it works. Martin Fowler once said something very wise. Any damn fool can make a program work. It takes a real programmer to make it right. Actually, he said it a little differently, but that's good enough. That's close to Martin Fowler's wording. Anyway, what could we do to improve this? Well, so I went through, I was just kind of bumming around in that code one day, and I saw this and thought, oh my God, who wrote this? Now, fortunately, fitness was written with test-driven development. We started this project in the year 2001, I think. And we wrote the whole thing with test-driven development. To this day, it is written with test-driven development, which means that we had a unit test in there for everything. And this function had a whole bunch of unit tests. That's how we knew it worked. This function worked because we had unit tests. And because we had unit tests, when I saw this code several years later, and I thought, oh my God, this is a mess, I was able to clean it because I had tests. I never had to worry that I would break it. Have you ever had that problem? Have you ever, looked at the code on your screen and thought, oh my God, that code's a mess, I should clean it? And your very next thought is, I'm not touching it. Oh my God, no, not me. I'm not touching it, because if you touch it, you'll break it. And if you break it, it becomes yours forever. So you back away, man. You're not going to be the one. No, no, no. And of course, if that's how you treat the code, then the code must rot. The only thing that can happen to the code is that it must rot. It must get worse with time, because no one is willing to do the one thing that would improve that code: clean it. But if you have tests, oh, well, then you can clean the code. Then you're not afraid. You're not going to break it. You've got tests. So this is what happened, about halfway through. This was the halfway point, when I was about half done refactoring this module. So take a look at it. In fact, I'll just walk you through it because it's not that big. Notice that the name of the function has changed. Render page with setups and teardowns, it's now called. Now, that's a verb phrase, right? And it tells you what it does. It renders the page, turns it into HTML. See down here? It renders it into HTML, and with the setups and teardowns. Good, yeah, that's exactly what it does. And let's look at the code. If this is a test page, that whole, has attribute test thing is gone. And by the way, you see it here, right? I've got this nice little variable, and I just set it to this expression here, page data has attribute test. And the only reason to have this variable is so that this line can read that way. If is test page. Remember, it's got to read like well-written prose. That's how you make code read like well-written prose. Yeah. By the way, this is one of the patterns in Kent Beck's best practice patterns. This is called explanatory variable. Anyway, if it's a test page, Well, then we get the wiki page. Oh, there's that string buffer again. Damn it. Still going up and down the in abstraction hierarchy. But then we include the setup pages. We append the content. We include the teardown pages. We set the content back into the page and we convert it into HTML. Pretty easy to understand, isn't it? Doesn't take, 2.5 minutes. And by the way, you probably didn't understand it in that 2.5 minutes. If you wanted to really understand that original bit of code, probably would have taken you 15 minutes, 20 minutes, 30 minutes to understand. Yeah, this doesn't take anywhere near that amount of time. You look at that and go, okay, there's some complexity in there, some weirdness, but most of it is pretty straightforward. But we're not done. We're not done. Right? This could be much better. Much better. Here, let me show you the final refactoring of this particular function. The final refactoring of this function looked like this. Render page with setups and teardowns. If it's a test page, include the setups and teardowns. Convert it to HTML. Now, notice that it does not take a long time to understand that, does it? Nope. You kind of look at that and go, oh yeah, okay, great. Now, by the way, there's a whole bunch of detail missing here. That's okay. That detail doesn't have to be there because the original guy coming in here probably just wanted to make sure that it does what, it said it did. The function says it renders the page with setups and teardowns. And maybe you just wanted to look in there and go, oh, yeah, okay. Yeah, all right, if it's a test page, fine. Now, he might have wanted to know a little bit more. Maybe he wanted to know how you include setups and teardowns. Well, okay, but that's also a really small function. And it calls other little small functions and calls other little small functions. In fact, that brings us to the first rule of functions. The first rule of functions. First rule of functions is they should be small. The second rule of functions is they should be smaller than that. I want small functions, tiny little functions. I want functions that are so small that you barely can see them. How many lines ought to be in a function? How many lines can you put in a function? Well, what would you say to 5? What if all your functions were 5 lines long? How many indents do you think they'd have? How hard do you think it would be to understand each one of them? If it's 5 lines long, it's probably not real hard to understand. Oh, there's going to be a bunch of details you're missing. But if it's 5 lines long, probably pretty easy to understand, isn't it? Yeah, probably is. So this is my rule. I like the functions to be really, really small. Now, how do you get them that small? Well, that comes down to this whole one thing. What does it mean for a function to do one thing? Now, most of you are probably using an IDE like IntelliJ or Visual Studio or Eclipse or something like that. And this IDE probably nowadays has a refactor menu at the top. If you're using Visual Studio, I hope you're using ReSharper. ReSharper makes Visual Studio almost usable. So there's probably a refactor menu up there. And in that menu, there's a menu item called Extract Method. And you know how this works, don't you? You've done it before. How do you extract a method? Well, let's say you've got a big function on your screen. And there's a bit of it that you think could be moved into another function. So you take your mouse and you select that bit that could be moved into another function. Then you invoke extract method. And up comes a dialog box, and the dialog box asks you for the name of the new function, and it shows you the arguments it's going to pass in because it figures all that out by looking at the code. And you kind of go, yeah, those are the right arguments. And then it tells you what the return value is going to be, yeah. And then you hit the button, and it immediately takes that code out, replaces it with the function call, then it creates the new function, puts your code into that new function. And everything still works the way it used to. Now, that's cool. So what's one thing? Well, a function that does more than one thing can have one of those things extracted with the extract method function. So a function that does one thing cannot have anything extracted from it meaningfully. I mean, you could extract the entire body of the function into another function, but that's meaningless, right? A function does one thing if you cannot meaningfully extract another function from it. Now, all those guys over the years told us that our functions should do one thing. So how do we get all our functions to do one thing? Extract, extract, extract until you cannot extract anymore. Now you all think I'm nuts, right? You're all going, no, wait a minute. No, we're not going to do that, because if we did that, well, we'd have hundreds of little tiny functions everywhere. We would drown beneath the sea of little tiny functions. No, you won't. And the reason you won't is because you have to give them all names. And they have to be good names. And you will organize them so that the higher level functions call the lower level functions, and the names will read nicely. The names will be like sentences, and those sentences will fit into the keywords. And so you'll have if is test page, then insert setups and teardowns. It will read like well-written prose. And it will look like it was written by someone who cared. You still don't believe me. Most people don't, because, you know, my God, it's terrifying to think that you're going to be creating hundreds and hundreds of little tiny functions. And besides, if you create hundreds and hundreds of little tiny functions, you're going to obscure the structure of the code. All you'll see are these little tiny functions. You won't be able to see that nice indent pattern that we all love to see. That's exactly not what happens. Oh, you will obscure that indent pattern. Don't worry about that. But you do not hide the structure of the code when you extract like crazy. In fact, you expose the structure of the code. Why do you expose it? You expose it because you take all the detail away from the high level. Every function has all the detail removed from it. That's put somewhere else. So the only thing left is the high level message of that function. You expose the structure of every function by shedding the details to a lower level. This also creates something I call the step-down rule. The step-down rule is very straightforward. You start with a function at the top. It calls other functions, which then call other functions, which then call other functions. And every function lives at one level of abstraction, not multiple levels, one level of abstraction, and that level is just below its name. That's the step-down rule. Every function has a single level of abstraction in it, and that level is one below the name of the function. You can work that out for yourself if you want to, but you and I should probably move along here because there are a few things that we should talk about. Now, I already mentioned about how to do one thing, and that's by extracting until you drop. There's a few other things we should talk about. Let's see. I'm going to go forward here. Good. Yes, we should avoid switch statements. I need to say this much more carefully. In a function, a switch statement can be a liability. It's not always a liability. It depends on a few things. Here's what it depends upon. Does that switch statement, or might that switch statement, call out to other modules from its cases? If it might do that, then it's deeply problematic because that causes a bunch of outgoing dependencies from the function. And when you have many outgoing dependencies from a function, then any small change out there will cause that function to be recompiled and redeployed. You have thrown out this massive net of dependencies, and any one of those little dependencies out there will come back to you and force you to recompile and redeploy. And then anyone who depends on that switch statement must also be recompiled and redeployed. Now, why do I focus on that? Because one of the things that we are after here is independent deployability. We want to be able to break our systems up into components, and those components need to be independently deployable. To the extent that you have switch statements that cross through the components, you're not going to be able to independently deploy them. Now, what can you do about this? Well, it is trivial to take a switch statement and turn it into a polymorphic dispatch, right? You create a base class with all the operations you want to perform, and then you have a derivative for each case. You can work this out. Look up in Martin Fowler's Refactoring book. Look up replace switch with polymorphism, or you can just Google that, replace switch with polymorphism. You'll find it there, and see how easy it is to get rid of the switch statement, and this is what happens when you use polymorphism. You will take all those outgoing dependencies of the switch statement, and they will become incoming dependencies, incoming inheritance arrows. And that's not problematic at all. There's a fundamental rule here. When you depend on something, depend in the direction of higher level. Don't depend on details. Depend on high-level policy. Depend on abstractions. Don't depend on details. Use polymorphism, use inheritance to shield yourself from low-level detail. There's much more to be said about that. You can look up the dependency inversion principle. But let's move ahead. Yes, of course, you should use descriptive names. And let me give you just a few hints on names, especially for functions and variables. I'll go through both of them. How long should the name of a variable be? Well, it depends on the context. If you have a very short scope, then the name of the variables in that scope should be short. If you have a very long scope, then the names of the variables in that long scope should be long. Now, what do I mean by this? Well, imagine a for loop. And imagine the for loop has 3 lines in it. Well, then the variables in the for loop should all be very small. 1 letter, I, for I equals 0, I less than 20, I plus plus, perfectly fine. Who cares? You don't need to say index or index of the array. You don't need to do that. I is fine because it's a tiny scope. Nobody's going to care. You know, they're gonna see that I and go, okay, yeah, fine. Yeah, 3 lines of code, I, fine. On the other hand, the local variables within a function, well, a function might get up to 5, 6, 7 lines long. It depends on whether you're extracting properly or not. But okay, that's probably going to be a word. The arguments of a function, probably a word. What about the instance variables of a class? That's a pretty long scope of class. That could be 20, 30, 40 lines. I hope you don't have really long classes. That's bad too. So maybe 2, 3 words for instance variables. Any of you have global variables out there? Most systems have a couple of global variables, and there's nothing to be ashamed of. Everybody has a global variable here or there. I mean, how else are you supposed to, deal with global things? You don't want a lot of them, and you certainly don't want them named I. So global variables live at the very longest scope. They should have very long names. So this is the variable rule, right? The name of a variable, the length of the name of a variable should be proportional to the scope of that variable. Now, what about functions? Well, oddly enough, it's exactly the opposite rule. The name of a function should get longer the shorter the scope. A function at the huge global scope should be really short, 1 word. And I can demonstrate this to you really easily. Think of the function open, open a file. We would hate it if that were named open file and throw exception if not found. That would be terrible. At a really high level, we want our functions to be general. And a general function must have a short name. But when they start getting lower level, well, then they become more specific. And a specific function needs a longer name to describe it. So the methods of a class, they have a relatively large scope, but nowhere near as large as global. So the names of the methods of a class should probably be a word or two. What about private methods? Private methods have a very short scope because they're only called from a couple of places. Well, they should have longer names, like maybe 4 or 5 words. And what about private methods called from other private methods? Well, they're going to have really long names, aren't they? And imagine doing extracting. Extract till you drop. Extract, extract, extract. What are you extracting from? Well, at first you're extracting from a public method, but then you start extracting from private methods, and then you start extracting from them, and then you start extracting from them, and the names get longer and longer as you go down. They become full sentences. And those full sentences sit inside of if statements and while loops and function calls, and they become well-written prose. Some of you are probably using C#. In C#, you have these things, I think they're called attributes. Is that what they're called? I can't remember. But they look like variables, but they're really functions. But because they look like variables, we use the variable naming rule. Classes, we use the same rule as functions, right? The larger the scope, the shorter the name. The smaller the scope, the longer the name. And you can tell this by looking at derived classes. Classes that are subclasses always have longer names. They have shorter scopes, they have longer names. So that's one thing, the naming rule. Now, we can probably talk about one more thing before we're done. A function should not have a lot of arguments. And I like to put the limit at 3. It's really easy to understand a function that takes no arguments. It's pretty easy to understand a function that takes 1 argument, and it's impossible to get it out of order. It's pretty easy to understand a function that takes 2 arguments, and you're not very likely to get it out of order because there's only 2 possibilities, right? So it's pretty easy to remember. 3, how many ways are there to rearrange 3 arguments? 6 different ways, because it's n factorial, isn't it? Yeah, okay, you can probably, 3, you can probably do it. 4, man, way too many different possibilities, 24 different ways to arrange it, right? So I wouldn't even try, right? I like to limit it to 3. And by the way, there's another argument here. That pun was intended, by the way. The argument is that if you have 4 things that are so cohesive that they can be passed as a single unit into a function, then why aren't they an object already? And so that's the other side of that coin. Now, what about constructors? Well, same rule for constructors. I don't make any different rule for them. I don't want to have any more than 3 arguments. Well, what if the class has got more than 3 variables? Well, then use setters. Use setters for that. Don't put a whole bunch of arguments in the constructor. I don't want to see, comma, 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 comma. I don't want to see that. I want to have nice short constructors. And you think, well, using setters, that means you could construct it invalidly. And well, that's why you write tests, guys. You write tests so that you don't use an object that's not validly constructed. Anyway. I think that's probably enough for today. I hope you enjoyed this little jaunt through clean code. And with that, thank you all for your attention. I appreciate it greatly. And I will turn this presentation back to our original host. Adios.
Thank you so much, Bob. It's really helpful and really great session. I hope our audience will be enjoy it. Thank you.